Have you ever heard of someone so far ahead of their time it almost feels like they're a time traveler? Well, today we're going to talk about a mathematician and astronomer from ancient India whose ideas were, honestly, revolutionary. This is the story of Aryabhata, a mind that was literally living in the future. So let's start with an idea that's so basic to us now, we don't even think about it. But for most of history, this was a wild, world-shattering concept, a single thought that would completely change how we see our place in the universe. So, let me ask you a question. Who do you think it was? Now, if you're thinking Copernicus, maybe Galileo, you're not wrong to think of them, but you're off by about 1,000 years. The real answer comes from a text written way, way before them. And there it is. Boom. In the year 499, Aryabhata used this incredibly simple and beautiful analogy to explain relative motion. He was saying, hey, maybe it's not the entire universe spinning around us. Maybe we're the ones who are spinning. This was a huge deal, a complete break from the idea of a static Earth at the center of everything. Okay, so who was this person who saw the world so differently? Let's get to know the man behind that brilliant quote and see exactly where and when he came from. Now, what I want you to do is just look at these dates. Let them sink in for a second. Aryabhata was born in 476 CE, and he wrote his masterpiece when he was just 23 years old. Now, look at the date for Copernicus, 1543. That's a gap of more than 1,000 years. This timeline just perfectly shows how incredibly far ahead of the curve he really was. And that masterpiece, it's called the Aryabhatiya, and it's the only work of his we still have. And get this, it's not some huge, sprawling text. It's a masterclass in being concise. The whole thing is just 108 verses, written in a style that's so dense and packed with information that later scholars had to write entire commentaries just to unpack it all. And the sheer scope of this short work is just wow. It's split into 4 parts, and it covers everything. I mean, everything from huge cosmological timescales and trigonometry to geometry and algebra to figuring out where the planets are, and, of course, explaining the shape of the Earth and what causes day and night, which, as we know, he nailed. All right, so to make these kinds of incredible leaps in astronomy, you need the right tools. And for Aryabhata, the ultimate tool was mathematics. But he didn't just use math, he pushed it forward, refining concepts that, believe it or not, we still use today. You know this number. We all do. It's pi. And this value, right here, is what Aryabhata calculated. It's accurate to 4 decimal places, which, for his time, was unbelievably precise. For centuries, this was the best you could get. This is basically his recipe for calculating pi. It's an elegant little algorithm. But the most fascinating part is that one little word he uses, approached. Why is that so important? Well, some scholars think this means he actually understood that pi was an irrational number, that you could get closer and closer, but never find the exact final value. If that's true, it's a staggering piece of insight, considering that wasn't proven in Europe until the 1760s. Okay, this is one of my favorite little bits of history. It's like a game of telephone that plays out over 1,000 years and across 3 languages. So every time a student learns about sine waves in trig class, they are using a word that started with Aryabhata. He called it Artaja for half chord. That got shortened to ja. Arabic translators wrote that down as jiba. Then Latin translators mistook jiba for a real Arabic word, jib, which means pocket. So they translated pocket into its Latin equivalent, sinus. And sinus eventually became our English word sine. Isn't that wild? So, armed with this super-powered math, Aryabhata turned his attention to the heavens. And he started to explain what he saw, not with myths, but with pure, rational science. Back then, the common story for why eclipses happened was all about mythology. Demons named Rahu and Ketu were literally swallowing the sun or the moon. Aryabhata just swept all that aside. He said, no, a lunar eclipse is just the moon moving into Earth's shadow. A solar eclipse is the moon's shadow falling on the Earth. He even calculated the size of the Earth's shadow.
It was pure, observational, brilliant science.
All right, now get ready for this number. This was his calculation for the length of a sidereal year. That's the time it takes the Earth to make one full orbit around the sun. Just take a look at how precise that is. And to put that number in perspective, he was off by less than 3.5 minutes. That's it. To get that close in the 5th century with the kinds of instruments they had back then is just mind-boggling. In fact, his model was so good that centuries later, an 18th century French scientist actually found that Aryabhata's tables predicted an eclipse more accurately than his own modern European charts did. Now, work this important doesn't just vanish. Aryabhata's ideas traveled. They were translated, studied, and they created ripples that we can still feel today. His legacy is an echo that has lasted for centuries. I mean, his fingerprints are everywhere. His work got translated into Arabic and was a huge influence on science in the Islamic Golden Age. From there, his ideas and his tables made their way to Europe. His calendar math is still a part of the Hindu calendar today. And in our time, his name is on India's very first satellite, a crater on the moon, and, get this, even a species of bacteria they found way up in the stratosphere. From ancient math to modern science, his name is still out there. You know, the story of Aryabhata really forces you to ask a pretty deep question. When you see someone who understood our world with this much clarity a millennium and a half ago, it makes you wonder, right? How much of what we think of as modern discovery is really just us rediscovering or catching up to an incredible wisdom that's been there for a very, very long time? It's definitely something to think about. Thanks for joining us.